Hello everyone and welcome back to your channel of Math and Engineering Made Easy. And today we are going to start a new topic of exponents and laws of exponents. When we say the laws or the rules of exponents, what do we mean by an exponent? Usually when I multiply a number by itself, let's say I multiply 3 by 3, we call that, how many times did we multiply the 3 by itself? Two times, right? 3 and 3. So we write this as 3 with a small 2 on the top, and we call that 3 square. Notice that if you have a square with a side of 3, you say its area is 3 times 3. That's exactly why we call that a square. If you multiply the 3 by itself 3 times, you write this as 3, and then you put a small 3 on the top as an exponent. We call these small numbers the exponents and the large numbers or the big numbers as the base. So we refer to that as a 3 cube. So when the exponent is 3, we call it cube. Why? Because if you have a cube with a side of 3, we say its volume is 3 times 3 times 3. So that's why we call that 3 cube. And you can increase that as many times as you wish, meaning I can say 3 to the 7th, meaning 3 multiplied by itself 7 times. It's easier than to write 3 times 3 times 3 times 3. And then when I look at it, I may count them incorrectly and count 6 instead of 7 or 8 instead of 7. Or if the number is so large, I don't know how many times did I multiply it. So we use the exponent, first of all, to simplify these multiplications. And now, if I tell you, okay, what if I multiply 3 square by 3 cube? What do I get? What is 3 square times 3 cubed? Well, 3 square is 3 times 3, so I can replace it by 3 times 3. 3 cube is 3 times 3 times 3. Well, I ended up having the 3 multiplied by itself 5 times. Oh, guess what? The 5 is the 2 plus 3. So 3 squared times 3 cubed is 3 to the 5th. And we get the first rule of exponents. If I have the same base x raised to any power, let's call it a, and I multiply it by x raised to the same power, to the different power, which is b, I mean the same base, the answer would be x raised to the power of a plus b. So now the multiplication here transformed into addition of exponents. Now, if I do the opposite, if I divide 3 to the 5th by 3 cubed, you see that I will end up with 3 squared. Since 3 squared times 3 cubed equals 3 to the 5th, if I divide both sides by 3 cubed, I get 3 to the 5th divided by 3 cubed is 3 squared. Hence, I can say that the second rule would say x to the a divided by x to the b equals x to the a minus b. Division is the opposite of multiplication, as the subtraction is the opposite or the inverse of addition. So these are the first two rules, and you have to read them both ways, because sometimes you see a problem that tells you x to the power of 3 plus 5 equals what? So you have to see, oh, if it's an addition of exponents, we multiply the bases raised to the individual powers. Well, when I said, say 3 cube, I take this 3 cube and multiply it by itself. You say, oh, so 3 plus 3 is 6. That would give me 3 to the power of 3 plus 3, or 3 to the 6, right? But don't you see that when I multiply a number by itself, I call it that thing square? So likewise, I could have called this thing 3 to the third squared. You say, oh, can I have multiple x? Yeah, absolutely you can. Notice 3 times 3 is 3 square. So 3 cube times 3 cube is 3 cube square. And here you get the third law of exponents is that if you have a base raised to a power of a, and then this whole thing is raised to another power of b, that answer would be the same as x to the a times b. So the exponent becomes a multiplication. So multiplication is addition, division is subtraction, exponent is multiplication. So what would be the root? The root is the opposite of the exponent, and the opposite of multiplication is division. So if I have something that tells me what is the square root of 4 to the 8th, meaning I want two values that when I multiply them by themselves, I get 4 to the 8th. I want something that when I multiply it by itself, I get 4 to the 8th. Using the same logic, it must be 4 to the 4 times 4 to the 4. Where did this 4 came from? It came from the fact that if I divide 8 by 2, I get 4. Notice that when I wrote the 2 on purpose, by the way, because when we say square root, we never write the 2. The 2 is there, but we don't write it. I wrote it here just to simplify the work for you and to understand that if I tell you square root, we call it square root, right? Square meaning 2, but we don't write it. So I want you to be clear about that. So here we have another rule that says the bth root of x to the a equals x. Notice this is the opposite of that. Opposite of multiplication is division. So this thing would be 4 to the 8 over 2 equals 4 to the 4. So these are the first 4 rules. Multiplication of bases, it has to be the same basis, right? Very important that you don't confuse these things with if I tell you what is x to the a plus x to the b. Well, I don't know. That you cannot simplify it into something else. Notice the difference between these two. I only have multiplication and division. Same thing. If I say x to the a minus x to the b, I don't know. It may be anything depending on what is x, what is a, and b. But I cannot have a rule that transforms that into something else. Okay? So, rule number 1, when I multiply the same base with different exponents, I can make it a single base, the same base, with the sum of the exponents. The second one is the division, becomes subtraction. The third one is the exponent becomes multiplication. And the last one is the root becomes a division. Okay, next. We know that if I say, or we don't know that, we will know it now. If I say the fifth rule, what is x to the 0? 0? No, we are not guessing. We can do it in a slightly weird way. What if I tell you what is x to the a divided by itself? What is anything divided by itself other than 0? It's 1, right? If I say 3 divided by 3, 9 divided by 9, x to the a divided by x to the a, y divided by y, anything that is not 0 and you divide it by itself, you get 1. But referring back to the second rule, it says x to the a over x to the a is x to the a minus a equal x to the 0. So x to the 0 equals 1. Okay? X to the 0 equals 1. And finally, if you want to see something different, I may end up with a negative exponent. For example, if I have something that tells me what is x to the negative a? Well, do you see that I can rewrite this as x to the 0 minus a, right? Negative a is 0 minus a. But if I write it like that, and I look at this equation, you see how they look? It becomes x to the 0 divided by x to the a, right? Because 0, if I divide, I subtract the exponents. We just said that x to the 0 is 1, so that becomes 1 over x to the a. So when I have a negative exponent in the numerator, because this is a numerator, right? This whole thing is divided by 1. I can take the reciprocal and switch this into positive. Or if I have 1 over x to the negative a, it becomes x to the a. Same thing, I take the reciprocal. Notice this is divided by 1, so we don't write it. Say just x to the a. And of course, as you learned what we do with fractions, you multiply these two. 1 times 1 is 1, is the same as x to the a times x to the negative a. Right? X to the a times x to the negative a will give you x to the 0 or 1. And these real rules really are extremely important. We are going to use those. So maybe in the next session, this was a short one just to introduce these laws to you. Next time, we are going to look at how, if I have multiple things, so I have 3x squared y cubed times, 7x to the negative 4 times y cubed divided by some. How do I simplify that into just one fraction? And then we are going to look at how exponents are used in real life. Okay, so applications of exponents, and how, if I have an equation, how do I plot equations? So the exponents. So how do I graph exponential functions? And that should pretty much cover all the material we want to do with exponents. It's very important, but please understand these 6 rules. Of course, we can create more rules, but derived from those. Everything here is connected. But these are the most important rules that we will be using in this course. And I hope this was pretty straightforward. It was clear, nothing hard. Try it yourself. Try some numbers and see what you get, and check with your calculator and see if the result you are getting by using these rules is the same as, for example, if I say 3 squared times 3 cubed, use a calculator and multiply them, and then find 3 to the 5th, and you make sure that in this case you get 243 in both cases. So the same number, I mean. Otherwise, if you have any other comments or questions, please don't hesitate to let me know. I'll try to get back to you as soon as I can. Thank you very much for watching. Hope to see you soon.